everybody. So we are starting lesson 4.4 on solving algebraic inequalities today. So if you want to pause the video, grab your textbook, and open up to page 220, you can follow along with me. So what I'm going to do is just kind of a quick explanation of what an equation is versus an inequality, talk about some similarities and some differences, solve these kind of basic ones, let you try one through the ed puzzle. Then we will be doing an example of solving inequalities with a variable on one side of the inequality, and then we'll be solving inequalities with variables on both sides of the inequalities. And today we're just focusing on addition and subtraction with inequalities, because tomorrow we'll be tackling multiplication and division with inequalities, and there's a set rule that applies to multiplication and division only that doesn't apply for addition and subtraction. So that's why I've broken it up this way. So equation, that's what we've been doing, and so far in all of our algebraic work in this unit and in the last unit. We had expressions early on, right? Remember, those don't have an equal sign. Then we went to equations, which an equation has, I'll put that as a different, equation has an equal sign, versus the inequality has the alligator. I'm trying to write quickly. I'm really trying to keep my videos succinct for you guys. So inequality has the greater than, less than, equal to, greater than, or equal to, less than, or equal to. Okay, or not equal to. So inequalities have these, the alligators is what I'm going to call them just for your familiarity, but they're an inequality, whereas an equation has an equal sign. So as you've been learning for equations, we tackle this by combining like terms and isolating variables. Well, this is how we're similar. We do the same thing for equations as inequalities. We combine like terms, we isolate and solve for the variable. So you're going to do the same exact thing with an inequality. You're going to tackle it just like we've been tackling equations. So in this example, negative 3y plus 2 equals 5y minus 8. So I am going to combine the y terms, right, because I'm trying to get my variables on the same side of the equal sign. Remember, we always move the coefficient that has the smaller value. Negative 3 has a smaller value than 5. So I'm going to move my negative 3y over to the 5y. So negative 3y, the opposite of negative 3y is positive 3y, right? So now we've canceled those out. We have positive 2 equals 8y minus 8. So we need to get rid of that constant. The opposite of subtracting 8 is adding 8 so that they're equal to 0, right? Now I've got positive 10 equals 8y. I need to divide the coefficient by itself because we're trying to get the variable down to 1y, completely isolated. And 10/8 can be reduced to 5/4. So y equals 5/4. So in this equation, the only value for y can be 5/4. That's the only value that when you plug in for these y's, that will make these equal to each other to balance out, right? Each number on each side of the equal sign. We're trying to balance it out. With an equal sign, they have to be equal to each other. So y is the only value for that. So an equation, the variable can only have one value. Only have one value for the equation to be true. Okay, so this is a way that they're different. In an equation, a variable can only be equal to that value. It can only have one value to be plugged in or substituted and make this true. Whereas with an inequality, that's different because we're going to tackle it the same way, right? And say x plus 3 is greater than 4. And remember from when you first learned about inequalities, this doesn't change. The alligator eats a bigger number. So when it's facing that number, it means this is greater than the other term, okay? So x plus 3 is greater than 4. So I'm going to move my 3 over, take away 3, the opposite, and I get x is greater than 4 minus 3 is 1. So x is greater than 1. But how an inequality is different is there are like infinite possibilities for x to be equal to. X can be equal to 1.1. It can be equal to 1.01. It can be equal to 1.1 and 1,000. It could be equal to 11. I'm just picking all of, like, it could be equal to 5. It could be equal to 3.8765. It could be endless possibilities as long as the value for x is greater than 1. And that's because if we plug 1.1 in, well, 1.1 plus 3 is 4.1, right? 4.1 is greater than 4. I could do 1 and 100th. Well, 1 and 100 plus 3 is 4 and 100th. That's greater than 4. Same thing here. I'd end up having 4 and 1,000ths. Here, I would have 14 is greater than 4. 8 is greater than 4. 3, I'd have what? 7 and 8,765 10,000ths. The only thing I couldn't have, like, x could not be equal to 0.5, which is less than 1, right? It has to be greater than 1. Because if I plug in 0.5, 0.5 plus 3 is just 3.5. 3.5 is not greater than 4. So that would not, if I plug that in, it would not make the equation true. So you can't have your variable be, in this case, it has to be greater than 1. It can't be less than 1. And all of these are part of the solution set. That's what this term is, a solution set. This is indicating what your solution set will contain. It is saying all of your solutions, your set of numbers, have to follow that rule for x to be greater than 1 for this inequality to be true. Okay, so what I'm going to have you do is try a simple one on your own, and then we're going to roll into doing this with decimals, fractions, as well as graphing them. All right.